Hey everyone, let's talk about Python. Now there's many different ways to get started with Python in either Windows or Mac or Unix-based computing environments, but I think the easiest one is the one I'm going to show you now, which is using Google Colab. Now you can also get a local Python install with something like WinPython or Anaconda. I'll put links to those in the video description. But again, as far as sort of ease of maintenance, ease of getting started, I think Google Colab has literally everything you need just to sort of get comfortable with the language and how you can actually start applying it, whether you're interested in finance, Fintech, or data science. All of these have a lot of potential use cases for Python, including interviews. So, how do we actually get started? Well, all you need to do is just go to your Google search or any other kind of search and enter Google Colab. And that will take you to its page. Now, the nice thing about this is that this is a fully online virtual environment, so you really don't need to do anything but go to this link or enter it into search to find the link if you don't recall it, and then you can immediately get started. Almost immediately, I should say, because one thing that you will need to do if you go to create a new notebook, you will see that you need to have a Google account. But so long as you have that, and remember, there's nothing really too complex about creating a Google account. Many of you have Gmail accounts already. That's really your Google account login right there. And if you don't have one, you can easily create one for free. And once you've done so, and you sign in, then you can actually go on to create a Colab notebook. Alright, so here we are now. I've signed into my Google account, and as you will do so with yours, you can now go to File and create a new notebook. And this will actually give you access to a virtual machine that Google runs for you in the cloud. And again, you get completely free access to it. It will time out if you don't give it any inputs for a while, which does mean that if you're running a really long piece of code, you'd probably have to restart. But for our sort of simpler examples, this won't really be an issue. So what you see in front of you already is a Python prompt. So you can type in some relatively simple code and see what actually happens. Let's just do a simple mathematical operation first. All programming languages, of course, are equipped to deal with mathematical expressions. So let's just give Python a simple math problem to solve and see what it does. So you type the expression in. You don't even need an equal sign. You don't need any sort of end-of-line character like you might in Java or C. All you need to do is press enter. Well, not quite. If you press enter, that simply takes you to the next line. What you really need to do is press shift enter. That will actually enter this line into Python for it to compute. So shift enter, and it's thinking, and eventually we'll get a response, and we see that, not too surprising, 2 plus 3 does indeed equal 5. We can do a more complex mathematical operation. Let's say 2 plus 3 times 6, order of operations. That'll work out just as expected. You'll do the stuff in the parentheses first, then you multiply by 6. So in this case, we should expect an answer of, what do you think? 30. 2 plus 3 is 5, times 6 is 30. And again, no need for equals, no need for end of lines. Python is a very simple language in this regard. Now, Python is not just a calculator, of course, it's a programming language, which means that it can create variables, keep track of variables, update and perform operations on variables, and do things like feed them into functions, get the output of those functions, and give you some sort of final result. So how do we start working towards that from these simple examples? Well, defining a variable in Python is actually super easy. Much simpler, for example, than it would be in a language like Java or a language like C, where you have to declare what sort of variable you're defining, whether it's an int, a float, a string, a matrix. In Python, you simply say, all right, I'm going to have a variable A, and this variable will be taking on the value of, let's say, 6. And now what you've done is you've entered into Python's memory a new item, a variable called A, that has the value of 6. Now you see it didn't really give us much of an output, but that's because we didn't ask for one. If we want to tell Python to give us back what we put into A, we simply say A. Again, remember, press Shift-Enter to execute the contents of a cell, and it'll say, oh yes, A had the value of 6. We can analogously create a variable B, and let's say B is going to be a string denoted by either double or single quotation marks, and let's say B is going to be dog. Again, we don't need to explicitly declare that B is a string variable, whereas A is an integer. Python implicitly assumes, given what you've actually allocated, what value you've given to each of these variables, what their type then should be. So again, if we say, all right, Python, tell me what was the value of B, and it'll say, all right, B was a string, and the string's value was dog. And importantly, we can actually retype variables. This is something that's pretty unique about Python. On the one hand, it's a little bit dangerous because it can lead to programming errors, but on the other hand, it's tremendously freeing because, let's say we no longer want B to be a string variable. Let's say we want B to actually have the value of 7. In a language like Java or C, this would give us a programming error. It'd say, wait, you declared B to be a string before. You can't assign a number to it. But Python doesn't care. If we say now, tell me what B is now, B is now indeed 7. It is no longer a string. It is now an integer. Now, that's variables. The next useful thing to think about, I think, as you sort of come to first grips with what programming in Python can do, is to think about applying functions to variables. So let's do this with a simple example as well. We'll need to create a function, and as you know from math, functions operate using inputs, things that you pass to the function, and outputs, things that it passes back to you. And the way that you create a function in Python, like the way that you create variables in Python, is very, very simple. All you do is say, I'm going to define a function. So you say def. And what follows, Python knows, will be the name of a function. And let's say we're not tremendously creative, so we're just going to have a a function name of f. Now we know that functions are functions of something, and as in math we denote function of something with parentheses, so f of something in parentheses. And in this case, let's say it's going to be a function of one variable, which will be x. And that's it. Again, you don't have to say that this function is going to take in a certain type of variable. You don't have to say this function is going to return a certain type of variable. All you say is function name and how many inputs it has. And then you just say colon to denote that you are done defining this function. Well, at least you're done defining its name. Now you actually need to go to the next line or lines to actually begin defining what this function is going to do. So if you press enter, remember Shift-Enter will execute the contents of a cell. Enter will actually just take you to the next line in the cell. Now if you do this, you'll see that we actually begin on an indent. Normally, of course, our start of line is all the way over here, but you notice we started a couple spaces out. And this is an important quirk of Python, that whenever you have something that is part of a larger structure, let's say a for loop, a while loop, a function definition, Python denotes that using indentations. And you can indent using spaces, or you can indent using tabs. Interestingly, you cannot mix and match, and that's led to some ideological debates. Here, we're using spaces. So now we're going to have to, on this indented line, actually say what this function that takes in a variable x is actually going to do for us. So let's say what this function is going to do is it's going to take this variable x and it's going to square it. Now you might remember from Excel or another programming language that a way to get Python to, or well, a programming language to square something is to take caret and then the power of 2. Actually, Python is a bit different. Here you take double star. Of course, single star would be multiplication. Double star is exponentiation. So x double star 2 means x to the power of 2. Now what that's going to do is it's going to take x and it will square it. But we still need to do one more thing, which is to say that to this function that we now want what you've done back. Which means, as you've probably seen in other programming languages, we need a return statement. Now this function should actually be complete. We have a function that takes in a variable, squares it, and gives it back to you. Now, as you notice, if we press enter again, that'll take us to the next line. It'll still be an indented one because Python isn't sure. I mean, technically, once we've entered in a return statement to a function, that function's pretty much over. But Python isn't 100% sure of that, so it still takes us to an indented line just in case we want to do more editing to this function f. But we're done with it. So that means that what we can actually do is tell Python we're now finished with function f, and we do this by simply going back to the start of the line. Once we've removed the indentation, that means that that function definition is over, and now we're just going to have some other code unrelated to the function f. Well, so one thing we can do is we can now actually have a new line of code in which we use function f. So let's say we're going to call f of 2. And this brings up an interesting idea about sort of the power of the Jupyter Notebook as a programming environment. You can see that we can actually have multiple lines of code per cell. Previously, we were just running them one at a time. We've got 3 lines in this cell. The first one gives us the name of the function we created. The second one gives us what this function is going to do. And now the third one is going to actually execute this function, give it the value of 2. And we can do all 3 at once. Of course, you can execute a bunch of commands in any programming language by just typing them into a editor, either a text editor or a specialized programming editor, but in a way that's more cumbersome than what this notebook environment provides, because here you can run little bits of your code just by themselves, just for the once, then edit them, run them again without messing anything else up. So in this sense, this notebook environment is actually really ideal for, first of all, just messing around with the programming language, but also for modifying a program, debugging, just a really flexible way to execute little bits of code at once without affecting anything that comes before it or after it, so long as the whole program, of course, executes in sequence. So let's run these 3 lines of code and see what happens. Remember, enter will take us to a new line, but we no longer want that. We want shift enter to actually run this bit of code. And you see that the answer, hopefully, is not a surprising one. Remember, we defined this function to take in an argument and return it square. We then gave that function in the last line of that cell an argument of 2, and this function now returns to us the square of 2, which of course is 4. Now it's important to note here that this x variable is defined as x only for the purposes of this function. If we now try to tell Python, hey, give me x, well, Python will say, what's x? It's not defined. And you might say, wait, of course it's defined. It's 2. I sent that as the value of x into the function f. This brings up an important idea in programming called scope, where programs really only see bits of a data environment that's sort of suitable to where you're looking. So function f knew what x was. X was 2. But sort of the top line environment doesn't, because you never actually defined x in it, which is exactly the issue that we're seeing now. And furthermore, the variable that we defined as x for the purposes of this function f, it can really be any variable. For example, remember how we did define a variable called a. Python remembers that. A is 6. We can actually now execute our function f by giving it a. So if you're wondering, wait, shouldn't we be saying f of x? Well, again, x is just a variable for the purposes of just the function f. It's literally saying whatever you get, we're going to denote it x temporarily, we're going to square it, we're going to spit it back out. That's really where the namespace of x is really only relevant. So we very much can run f of a, and what we should expect as the answer is, well, if a is 6, we should expect 6 squared back. And so it is. Now, what if we do f of b? What do you think will happen? Well, previously we did define b, right? We first defined it as a string, and then we defined it as an integer. What do you think will happen when we run f of b? Well, if this answer does not surprise you, that's good. Remember, each time we redefine a variable, it essentially overwrites it. So even though previously we said b was a string, and later we said b was the number 7, it's the last thing we say that goes. So when we say f of b, we're saying f of 7. And when the function then takes 7 and squares it and spits it back out, of course we know that the result is going to be 49. Now, just out of curiosity, what would happen if we had redefined b to be dog again? Incidentally, we don't even have to create this new cell. And if you ever want to get rid of a cell, you simply go right-click on it and say delete cell. Because remember, we actually had this cell up here. So one cool thing about notebooks is, as I was saying, you can rerun a bit of code without messing up anything else. So let's say we go back here and now we say, all right, actually b is dog. So now we've said b was dog, then we changed b to be 7, and now we're saying b is back to being dog again. Now what happens if we run f of b? Well, obviously Python is going to complain. And what it's going to complain to us about is type error, because the mathematical operation square is just not really defined for strings. There's no settled way of taking the square of a string. Obviously, there's some ways that we could think about doing it. Each letter has a numerical value, We could maybe take the square of each letter and add them up and return them, but who's to say that that's the right way to do it? So the people who designed Python as a programming language simply sidestepped that whole mess and said, we're not going to define what the square of a string is, and if anybody is silly enough to ask, we'll simply tell them that that is not something they should be doing. And that's Python's way of telling us just that. The exponentiation operator does not work for strings. So now we can actually go back to this cell that sets b to an integer value and run that. And now, of course, it shouldn't surprise us that now we're going to get back a reasonable run of the function f, because now we've set b to a supported data type, which is to say a number, for which exponentiation does work. So far, so good. This is sort of like the basic functionalities of a notebook, but it's not all. One other really useful thing is actually the ability to comment on what you're doing. Obviously, if you've written in something like Java or C or any other programming language, MATLAB, what have you, you know that you can create comments in your code, and so you can in Python. You can actually say this. If you preface a line with a hashtag mark, that will actually simply be a commented line. It won't be executed. If you run it, nothing happens. And this is, of course, one way to create comments in Python. But one really cool way of creating comments in a notebook is as follows. If you simply hover your cursor here between any two cells, you actually see these two boxes pop up. You can insert another cell with code. So if we previously defined a to be a certain value, and then we said, oh wait, actually we want a to be something else. We want a to be the same value that b has. Well, we could do that here. But let's actually not do that, and let's look at this other box, which says text. This is a way that we can actually create comments about what we're doing right in the middle of our various code cells. So you see this looks very much like a text editor. You can have various headings. You can have bold and italic. You can even have a bit of code. You can insert a link, a picture. You can do alignment, lists, bullet points. So a simple example is, let's say that we're about to set the value of this new variable called b. We can actually denote that in this box. So we can say, let's set the value of b, a new variable called b, like so. And once you execute that, you actually execute a text cell the same way that you do a program cell, Shift-Enter. You can now see that we have a bit of text here. And if we double-click on it, we can go back to edit it. And if we Shift-Enter again, we will now update. Now, another really cool thing about these text cells is that they also accept mathematical formatting. And you can enter the math environment by entering the $sign twice. If you're familiar with the markup language called LaTeX, this will be familiar to you. There, of course, you use single $signs to denote the math environment. Here you use doubles. And in the math environment, what you can do is you can create equations. For example, let's do a simple one. Let's say we're going to define what the formula for present value is. So above that, let's say we'll just have some plain text saying that this is going to be the formula for present value. And below it, let's actually write out what the formula should be in math terms. The formula is going to be your present value, let's say denoted by the variable PV. And that is going to be an equation. PV is equal to, well, what's it equal to? If you've got a single cash flow, it's just your future value discounted at the number, at the discount rate, exponentiated to the number of periods. The way you do this is you actually use notation very similar to that of LaTeX. You'll say /frac to get a mathematical fraction. In the first set of brackets, you'll enter future value. In the second set of brackets, you'll enter, if future value is your denominator, the second thing is going to be your, if future value is your numerator, the second thing is going to be your denominator, which will be 1 plus your discount rate to the number of periods. And we end the math environment there, except of course it's not going to be to the square, it's going to be to the number of periods n. And you see that actually we get a little preview of what we've entered here. By the way, note that since we're using LaTeX notation, not Python notation, we can actually get away with using caret for exponentiation. And if we were to do this, that actually would not work, simply because here we're in a text cell, not a Python code cell. So when in Rome, do as the Romans do, and when in text cells, use the rules of text cells, not the rules of Python. But now if we want to execute that, again, Shift-Enter, we actually see that we now have a formula. Now, why do you really want to go to all this trouble of putting together these various text cells, and why would you ever want to create complex mathematical equations in them? Well, if you're doing finance applications of Python, for example, you're doing a multi-factor regression model, maybe you're doing a factor-based risk model, maybe you're pricing derivatives, Python actually has a tremendous number of powerful tools that can help really any finance practitioner, as well as a data science practitioner, anybody in Fintech. That means you probably may want to describe what you're doing to someone who's relatively new to your code. Maybe they've never seen your code before. So you actually can find it quite useful to throw in a mathematical equation every now and then, and definitely to throw in just some text describing what it is that you're about to do. So this now is, I think, a decent coverage of sort of the basics of what you can do in a notebook, how you can run some code in cells, sometimes quite a bit of code, how you can mark up your notebook by inserting text and even mathematical equations. Let's wrap up with a couple of tools that the notebook provides you just in terms of sort of ease of use. First of all, if you ever want to rerun your notebook, you can go to Runtime and run it. That'll just run through your entire set of cells one by one. Sometimes you might get stuck on something, and if you really want to be sure that what you're doing is sort of a factory reset of your notebook, as it were, something's just not working right, one way to debug it would be to say restart and run all. It'll still preserve all of your cells, it'll still preserve everything you've written, but it will literally start from scratch. Clear memory, start from the very beginning. So restart and run all. It'll give you a warning that means that, since you are clearing memory, all of your local variables will be lost. In other words, A will no longer have the value of 6, B will no longer have the value of dog, but that's all right. Since your code is still there, we can say yes to this, and those values will get assigned back to them. And now you see the program runs again, and all of our inputs, f of 2 is still 4, f of a is still 36, f of b is still 49, which is important because remember, first we initialize b to the value of dog, then we initialize b to the value of 7. The last thing goes, so that's why that bit works out. We can essentially get a clean run of the notebook anytime. Now the other important issue is how do you actually save the output of your notebook? You can actually do it in several ways. First of all, each time you create a notebook in Google Colab, it will already start existing in your drive. So you can simply go to File, Locate in Drive, and it'll open up your Google Drive and it'll show you where your notebook is virtually. You can also save a copy of it in Drive. That means that you'll just have another notebook that's identical to the one you're working in, still in your Google Drive. You can save a copy to GitHub, but that's a more advanced feature that requires you to create a GitHub account. That'll make it easy to share your code with others. You can, of course, just save your notebook to its current location in Google Drive. But let's say you want to actually export your notebook, either to send it to somebody else, maybe as part of an interview, or to deliver it as an assignment submission, or just to save a local copy. Well, for that, you can go to Download. And I'll give you two options. You can download the notebook, or you can download the Python code. Now, if you download the Python code, it'll essentially just give you a text file that has all of these commands that we entered in there. If you download as Python Notebook, it'll actually give you a file that contains all of the details of this Python notebook that you could then run locally if you had a way to run Python locally. And again, this would be something that you could do with something like WinPython or Anaconda, or perhaps an operating system that includes Python natively. But the other potentially useful way of saving your notebook is simply to print it. And for that, if you simply say print, you can see here a print preview that'll actually just let you literally save pages with the entries in your notebook. Depending on how you want to print them, you can save them as a PDF file, or if you've got a printer mounted, you could actually physically print them out. But let's say you need to submit your notebook as a PDF for ease of reading, especially for somebody who doesn't have a local Python implementation to open a Python file, then saying save as PDF is perhaps the easiest way to do that. So now if you click on Save, it'll actually give you a regular download dialog, which will let you save that PDF file to your local computer, where you can print it, send it to somebody else, save it to your disk, what have you. So in this lecture we learned, first of all, how to start Google Colab as perhaps the easiest implementation of a Python notebook, and just the easiest way to start playing around with Python. We learned how to put in some simple commands into the cell-based notebook structure, as well as to sort of augment it with text-based cells. And finally, we learned some basic utilities of the notebook, like restarting it, erasing all of the prior data and then restarting, and how we can actually use it to export our code, either as a Python file, a notebook file, or a PDF file. Thanks for listening.